Hi, good afternoon, everyone. This is the last topic of matrices and determinants that we are covering today. And from the next class, we will go ahead and we will start with vector, right? So we want to go ahead and we want to understand what are linear equations and how to solve two kind of linear equations, right? Before I go ahead and I move into what linear equations are and how to solve them, I would like to summarize linear equations for you, but I would like to go ahead and I would like to do it for a two variable case, right? Once you understand what happens with a two variable case, all proper things are, then this lecture will be very easy for you. So let us go ahead and let us try to understand first of all, what is a linear equation? A linear equation in n variable x1, x2 till xn is of the form a1, x1 plus a2, x2 till an, xn equal to alpha. So for a two variable, if I write a1, x1 plus a1, x1 plus a2, x2 is equal to alpha. Any equation which is of this form, but this is called as linear equation. This is called as linear equation. Okay. Now these a1, a2, etc., these are called as coefficients of this linear equation. So whether I am talking about n variable case or two variable case, these AIs, they are called as coefficient of xi's, right? These AIs, they should belong to real number, real space. पॉजिटिव भी हो सकते हैं, नेगेटिव भी हो सकते हैं, फ्रैक्शन भी हो सकता है, रैशनल नंबर भी हो सकता है. इट कैन बी एनीथिंग बिलोंगिंग टू रियल स्पेस. And this alpha, it is basically a constant term of the equation. Alpha is the constant term of the equation. So so now let's go ahead and let's take an example. Let's take this example 1. But let's see this. 2x plus 3y is equal to 6. 3x plus 2y is equal to 6. First, let's try to look at these two equations. Let me try to plot these two equations. एक बार इनको plot करके देखते हैं what will go ahead and happen. So if I go ahead and I take x here and I take y here, I will have 1, 2, 3, 1, 2, 3. So this can be rewritten as x by 3 plus y by 2 equal to 1. ऐसे लिख सकते हैं. Just try to understand this thing. Can I go ahead and can I divide throughout by 6? And can I get this? It means that the x-intercept will be 3 and the y-intercept will be will be 2. The x-intercept will be 3 and y will be 2. 3, 2. You join them and you get a line. Now look at the next one. The next equation goes ahead and it says 3x plus 2y is equal to 6. It means if I divide throughout 3x plus 2y as 6, if I divide throughout by 6, I will get x by 2 plus y by 3 is equal to 1. So x is 2 and y is 3 and I can join this. This gives me a unique solution. This gives me a unique solution, right? The lines are intersecting exactly once. So if the lines are intersecting exactly once, it means I have a unique solution with me. Now, what I can go ahead and what I can therefore do is I can solve these two equations simultaneously. So I have 2x plus 3y equal to 6. 3x plus 2y equal to 6. One way in which we can solve these equations can be by writing this in the augmented format and bringing it to row reduced echelon form. Bringing it to row reduced echelon form. What does it mean? It means that I can go ahead and I can write this as 2, 3, 3, 2 into x, y equal to 6, 6. All this first matrix that you see here, this matrix is your coefficient matrix. This is your variable matrix. This is your constant matrix. And I can easily see that I am getting A, X equal to B. A, X equal to B. So this is my matrix A. Coefficient matrix. This is the matrix of the variables, matrix X. And this is the matrix of the constant. Right? Try to notice something here, which is important, which is that, if I just open this up, I will get this into this plus this into this. So equal to this. So I will get the first equation. Similarly, if I try multiplying this into this plus this into this equal to this, I will get the second equation. Which means that equations can be represented in the form of a matrix. Now, from here, we can have something which is known as an augmented matrix. An augmented matrix will go ahead and look like this. A dash B. So let us go ahead and write this in the augmented matrix format, and we will get 2, 3, 3, 2, 6, 6. Right? Now I need to go ahead and I need to convert this in the row echelon form. So what I need 1 here. I need everything below this 0. And I need to the right should be 1. This is how we convert. So I need to go ahead and I need to convert this in the row echelon form, right? So what I can go ahead and I can therefore do is I can do R1 goes to R1 divided by 2. So I will get 1, 3 by 2, 6 divided by 2, 3, 3, 2, 6. Then I can go ahead, now I need this to be 0, right? So I can go ahead and do that R2 goes to R2 minus 3 times R1. So I'll get this as 1, 3 by 2, 3, 3 minus 3 is 0, 2 minus 3 times 3 by 2, 2 minus 9 by 2, 4 minus 9 by 2, minus 5 by 2. 6 minus 3 times 3, 6 minus 9, minus 3. And I will go ahead and get this. Right? Now, if I further solve this, what will happen? I can have R2 goes to R2 divided by minus 5 by 2. So that I get a 1 here. So I will have 1, 3 by 2, 3, 0, 1. And this will become minus 3 divided by minus 5 by 2, minus 3 into 2 by minus 5. So I will get 6 by 5. right? Now, the first column represents variable X. The second column represents variable Y. So you always start solving from the last row and you go up and up and up. So if I go ahead and I look here from the last row, what will I get? 0 into X plus 1 into Y is equal to 6 by 5. So Y will be 6 by 5. I've got the value of Y. Now you solve 1 up. So you will get 0 into X plus 3 by 2 into Y is equal to 6 by Y is equal to 3. This is, sorry, 1 into X. You're going next row. 1 into X plus 3 by 2 into Y is equal to 3. And you will put Y as 6 by 5. So 1 into X plus 3 by 2, 6 by 5 equal to 3. 1 into X plus 9 by 5 equal to 3. X is equal to 3 minus 9 by 5. 15 minus 9, 6 by 5. I hope this is clear to you. So we are picking one row at a time in this matrix. After we convert this in the row echelon form, we are picking one at a time. So there are two equations that are formed here. The second row, from the second row, the equation that I go ahead and I get, that is this. That is 0 into X plus 1 into Y equal to 6 by 5. And from the first row, the equation that I will get will be 1 into X plus 3 by 2 into Y equal to 3. Right? And then you can go ahead and you can solve for X and Y. This is your first case, case 1, where you have a unique solution. Where you have a unique solution. Right? Now, the next thing that we need to go ahead and we need to understand is case number 2. Let's say I take the same equations that I have taken, but I just manipulate this a bit. So I say 2x plus 3y is equal to 6. And I say 3x plus, or let's change this a bit. So I say 4x plus 6y is equal to 12. 4x plus 6y is equal to 12. Let's first try to see the plotting of these equations. So if you notice here, if I try to plot this one, what will happen? 2x plus 3y equal to 6. I divide throughout by 6. I get x by 3 plus y by 2 is equal to 1. So if I were to go ahead and I were to take x here and y here, I'll get x as 1, x as 2, x as 3, y as 1, y as 2, y as 3. So intercept is 2 and 3 here. So this is my line that I will get. This is the line that I will go ahead and get. Right? Now look at the second line, beta. Look at this line. So I am going ahead and I am getting 4x plus 6y equal to 12. Right? Again, I will divide throughout by 12. So I will get x by 3 plus y by 2 equal to 1. And I will get exactly same line. So it means that both these equations, they represent the same line. Ultimately, I just have one line, but I have two variables, x and y. So there are multiple values of x and y that can satisfy this line. I can have one value here, one value here, one value here, one value here. All these values, all these coordinates are going to satisfy both the lines, isn't it? Because there's just one line. There is no intersection. Both lines are coinciding with each other. So we can say that there are infinite many solutions. There are infinite many solutions. Now let us try to see some additional things here. Now if I go back to case 1 and I only focus on matrix A, just focus on matrix A. What do we notice here? What do we find out here in matrix A? We find out that if I were to find the determinant of this matrix, 2, 3, 3, 2, we will get the determinant as 2 into 2 minus 3 into 3, 4 minus 9, that means minus 5. So I am getting a non-zero determinant, which means that this is a singular matrix, non-singular matrix. It's a non-singular matrix. Let us try to go ahead and compare this non-singular matrix with the next matrix that we see here, where we see infinitely many solutions. So what happens here is that if I try to find the determinant of A, I will get 2, 3, 4, 6. So my determinant will become 2 into 6 minus 3 into 4, and it will be 12 minus 12, and it will be 0. So I will go ahead and I will get the determinant as 0. Now let us try to go ahead. So it's a singular matrix. We have got one thing. But let us try to go ahead and let us try to find augmented matrix. So I have 2, 3, and 6 here, right? And if I go to the next one, I will get 4, 6, and 12. Let's do some transformations. So R2 goes to R2 minus 2 times R1. And what will I get? 2, 3, 6, 0, 0, 0. Right? And I will get R1 goes to R1 divided by 2. So I'll get 1, 3 by 2, 3, 0, 0, 0. Right? This is my variable X. This is my variable Y. So there are two variables. But there is only one valid equation that I see. The second equation that I see here, this is 0x plus 0y equal to 0. This makes no additional information to us. It gives no additional information. The only information which we see is that x plus 3 by 2y equal to 3. So I have two variables, right? And I just have one equation. So I need to set one variable free. I need to set one variable free. What does it mean? It means that I will say, okay, let y take the value 1. Then I can find x accordingly. Let y take the value 2. Then I can find x accordingly. So I need to keep y free. You can give any value to y. You can give any value k to y. Whatever this k will be, k can be 1, k can be 2, k can be 3, k can be 10, 20, 40. Accordingly, x will take values, right? So you can say that x will be 3 minus 3 by 2k. Y has been given the value of k. If I just put k here and find x. Now, as this k changes, k can be 1, k can be 2, k can be 10, 20, 40, 50, the value of x will change. So there will be infinite solutions that you will be seeing here. Let us now go ahead and now talk about the case number 3 better. So this is interesting. When we go to case number 3, what we go ahead and what we understand here is that I'm going to take very similar equations, but I'm going to go